Question number 1 pertains to functions and understanding functions. So with this example, you have to remember that functions must pass the vertical line test. And you cannot repeat x values, meaning that x, or the domain, which means x, which also means input, has only one output. Okay? So you're trying to look, in this example, which statements below, so there could be more than one, are false, which are not true, when defining a function. For every input, there may be more than one output. So that is definitely false because you cannot repeat x's. So a non-function, something is not a function, would be something like 2, 3, and then also 2, 4. Okay? It would not pass the vertical line test, and it also repeats your x value, so it's not a function. For every input, there is exactly one output. That's a function, so it's not false. That's true. All y values map to one x value, and this one actually is false because your y values can repeat. So your y values can repeat. Okay, so that's false. That can still be a function. And then all x values map to one y value. That's what we referred to in the beginning with what a function is in its definition. So that's true. So 1 and 3 are the false statements. Which statements below, so more than one is possible, state how you can tell, so these are true, if a relation is a function. Select all that apply. If given a graph, the relation passes the horizontal line test, and that does not tell us if a relation is a function, so that's not true, that's false. If given a graph, the relation passes the vertical line test, so something like this, a parabola, if you drew a straight line through it, it would only go through that parabola, that relation once, so that is a function, so that is a way you can tell. Each input maps to exactly one output, that is true. So if you had a list of x values, 1, 2, 3, and then y values, 4, 5, 6, they would map to only one. But remember, we can repeat if we wanted to. We could repeat the y value. So we could have 3 actually go to 5. But there's only one x value listed, so that is a function. Each output maps directly to one input. That does not have to be true. We can repeat the y's, so that one is false. Okay? So option 2 and 3 are the correct statements in terms of functions. Now, example number 2 gives you a function and its rule, 3x minus 4. And they're telling you that it has a domain, so these are the x values, of -1, 3, 4, 7, and 9. They want you to state the range of the function. So literally what you are doing is plugging in for x each value that they're giving you. So if you plug in -1 into this function, 3 times -1 minus 4, either by mentally you can do that computation, or you could also put in your calculator. You'll get -7. So that is your range value when x is -1. Okay? And if you repeat this process, you'll end up getting that f of 3, when you plug in 3 for x, is 5. F of 4 gives you 8. F of 7 gives you 17. And f of 9, when you plug in 9 for x, you get 23. So if you want to state the range values would be in that order that they gave you for the domain. -7, okay, 5, 8, 17, and 23. And you put it in those brackets for your final answer. Okay. Same thing with B. Literally, you're plugging in for x, -3, 0, 2, 3, and 6. And when you put them in, you end up getting f of -3 gives you 5. F of 0, that gives you 8. When you plug in 2 for x, you get 10. When you plug in 3 for x, you get 11. And last but not least, plugging in 6 for x gives you 14. So your final answer in terms of the range would be 5, 8, 10, 11, and 14. The next example, number 3, given the quadratic function below, and remember for 3a, quadratic means it's a parabola, what is the domain and range? So for this graph, your x values are going on forever in both directions, left and right. So your x values get wider without stopping, okay? So that tells us that the domain will be all real numbers, or you can use the symbol for all real numbers. The range, though, starts here at -2 and goes up. So that means that your y is going to start at -2, so that's why we have it as greater than or equal to -2, because it keeps getting bigger. -1, 0, 1, 2, 3, 4, 5. These numbers keep getting bigger, so that's why you know it's going to be greater than. Okay. For part B, given the function below, what is the domain and range? Now this function starts right here at the origin for both x and y at 0, 0. So what we can say when we're looking at the x values, we're looking left and right. There's nothing to the left, no negative numbers for x, but there are 0 and numbers that are bigger than 0 for x. So that means that x is going to be greater than or equal to, also equal to, because there is a point at 0, 0, 0. Y, we look up and down for y. There are no negatives for y, but y does start at 0 and gets bigger, so the range is greater than or equal to 0. For number 4, I think the best bet for number 4 would be to actually go to your calculator, because they want to know which table matches up with this function, f of x equals 2x minus 3. So what you could do is go to your calculator, go to y equals, clear out anything that you might have, and type in 2x minus 3. Instead of graphing, we can literally just go to our table and compare and see if we have the same values that are listed in the options below. So number 1, choice 1, says when x is 0, y is positive 3. That can't be the case. Choice 2 says that when x is -4, y is -10. That is not the choice, because on the table it doesn't tell you that. When you look at option 3, you can see that when x is -7, y is -17. Check another point at -3, x is -9, 0, -3, and go up to find 8 and 13. That has to be the option. Just to double check that this answer is correct, we could check for 15 for x, and we get 27. So choice 4 is not the option. Part B, which of the following tables represents that function? Do the exact same thing. You check the tables, you see which ones end up having the same values, the same options that are given, and I did this one ahead of time. When you type in 4x plus 2, you can go to the table, check, and I checked ahead of time and I saw that the options for choice 2 worked out. -3, y is -10. When x is 0, y is 2. At 8, y is 34. And at 11, y is 46. So that is one way you can check. Number 5, determine which relation is a function. So again, function has to pass the vertical line test. Okay. You cannot repeat x's. Okay. So if we look at choice 1, okay, choice 1 is a function because your x values are not repeated. Your y values can repeat and still be a function. So 1 is a function. Choice 2, You notice that 5 is repeating itself with different values of y, so choice 2 is not a function. Try the vertical line test for this graph, and it crosses at 2 points, so it cannot be a function. Try the vertical line test again at choice 4, is not a function. So the only possible answer is the first option. Part B, determine which relation is a function. Select all that apply. Again, we're using the same properties. No x value repeats. It's okay if the x value and y value are the same. That will work. Notice how 2 repeats, not once, not twice, but on 4 different occasions, 4 different points, we have 2 repeating, so that cannot be a function. Choice 3, x values look okay, no repeats. That's a function. And then this figure right here, although the vertical line test would work on the left-hand side, when we get to this right-hand side, we have a straight line, a vertical line, so that would not pass the vertical line test. So 1 and 3 are the only options for functions. And then 6, state if the following sets of ordered pairs are a function or not. Explain. That means that you want to write in a complete sentence, of course. So we look at the x's. We notice that the x's do not repeat, so the set is a function. And the reason is because none of the x values, or we can call those inputs, repeat. Choice B, we notice that we have different values of x until we get to the end. We have 2 that repeats, and they are mapped to different y values, so the set is not a function. And that's because x equals 2 is mapped or associated with both 11 and 2.